Hello, all right, I'm Teacher Ko here. All right, so in this video, I'm going to go through this matter revision. So let's go. But once again, before you go through the video, if you can attempt the questions first before you look at the solutions so that you get to have a chance to think about it. Okay, so let's do a recap first. Right, so what is matter? Matter is basically anything that has what do the matter have? Let me, where's my stylus coming? Okay, so matter is anything that has mass and occupy space, right? Another word for occupy space is volume. All right, has mass and volume. Okay, so there are basically three states of matter. So when we talk of, we mention the word states. Okay, you must know what's the meaning of states. There are three states of matter, which is solid, all right, liquid, and gas. These are the three states of matter. All right, so matter can exist as a solid state, right, in liquid and a gas. So what are the properties of solid, liquids, and gases? Now, these are the properties. This is what we call the properties. These are the properties of solids, liquids, and gases. So every time when the question asks you for a property of the solid, we are looking for either one of these four. Okay, property of liquid, one of these four, and gases, one of these four. All right, which is solid has mass, all right, has volume. All right, so you see the first two, every solid, liquid, and gas, everyone has the same property, right? Because solid, liquid, and gas, they are all matter. So solid, liquid, gas will all have mass, and solid, liquid, gas will all have volume because they're all matter, right? Or they occupy space. But the 3 and 4 properties, 3 and 4 will differ, right? Solid is it is special because solid has a definite shape. This is the main difference, right? Definite shape. That means it has a shape of its own. The shape is definite, right? So if a round object, right, you put a round marble onto the table or round marble onto the cup, the marble will remain as round because the shape is round. The shape is a definite round, right? But if liquid, it has no definite shape. If you put the water into a cup or you put it on the table, you put it into a round container, the shape will change depending on the shape of the container. So it takes the shape of the container. All right. Likewise, gas, it has no definite shape, right? So it takes the shape of the container. If you blow the air into a balloon that is a round shape, the air will take the shape of the round, right? If you blow the air into a balloon that is a Mickey Mouse shape, you will take the shape of the Mickey Mouse, right? So it takes the shape of the container. So this no definite shape means take the shape of the container. So this one is for the liquid and the gas. All right, but for the volume, right, solid has a definite volume, which means the volume of the space the solid occupies is definite. So if I have 10 books, you will need to occupy 10 books of space. Just like liquid, the volume of liquid is definite. If you have 1 liter of liquid, you will need to occupy 1 liter of space or 1000 cubic cm of space. But gas, the volume is not definite. It does not have a definite volume. If you have 1000 cubic centimeter of gas, you can compress it into a small container of, let's say, 500 cubic centimeter. It does not, the volume is not definite. You can compress them. Yeah, so because of that, we say that the gas can be compressed. All right, can be compressed, and liquid and solid cannot be compressed. Okay, so that is the 4 main properties of solid, liquid, and gases. So let's take a look at the questions now. So Susan used an air pump to blow some balloons as shown in the diagram below. Right, what property of air does this experiment show? Put a tick in the box or boxes. Now, the property of air, right? But we are looking for property of where air. So when you see property of air, we are looking for the four properties, right? The four properties, like what we have seen earlier, right? Gas have mass, gas have volume, gas no definite shape, and no definite volume. So these are the four properties of gas. But which one does this experiment show? Does this experiment show that air has mass? Does this experiment show that air has volume? Does this experiment show that air has no definite shape? Or does this experiment show that it has no definite volume? If, let's say, I were to choose only one, which one do you think is the best fit for this experiment? If I were to choose one, the best one would be no definite shape, right? Because it takes the shape of the balloon. So this is a heart-shaped balloon. The air will take the shape of the balloon. This will be the best. But does it show that it occupies space? Actually, yes as well. Okay, yes as well. It does show it occupies space. But I think if I were to choose one, I would choose no definite shape. If I can choose two, then I'll choose occupy space and no definite shape. Okay. Does it show that there's no definite volume? No, it does not, because it means that it can be compressed, right? But in this experiment, it does not show that it can be compressed. So I will not choose this one. Okay. So the next one. A sealed box have a capacity of 1000 cubic centimeter. Which of the following substances can the box most likely hold? So this is a capacity of 1000. That means it can hold a maximum of 1000 cubic centimeter of stuff, right? Can I put 1200 cubic cm of air in? 1200 cubic cm of oil? 1200 cubic cm of sand and oxygen? Now we know that air is a gas, oxygen is a gas, and gases can be compressed, right? No definite volume, right? Can be compressed. So even if I 1200, which is more than what the box can hold, but that isn't a problem because the gas can be compressed and squeezed into the box. So these two will definitely likely be able to go in. But how about the oil and the sand? Now, oil and sand, they both have a definite volume, right? They have definite volume so that it cannot be compressed. So it is too much. It is more than what the box can hold. They cannot be put into the box. Okay, so this showed us that gas that can be compressed, so it can be put into any container of any size if you want. Question 3. A stone is placed in the displacement can. The water in the displacement can overflows into a measuring cylinder. All right, so when you put the stone into the water, it will go into this container, all right, and the water will overflow, probably to this amount, roughly this. Okay, there'll be some water being displaced by the stone. So, what property of stone does this experiment show? Now, does this experiment show that stone has mass? Right, this is how do you know whether an object has mass? You need how do you measure mass? Yeah, you either use a weighing scale, all right, or a lever balance. These two are instruments that you can use to measure mass or compare mass. All right, and every instrument can only measure one property. So weighing scale is used to measure mass alone. You cannot use a weighing scale to measure measure volume. Okay, so you know how much mass you use a weighing scale, you use or a lever balance, right? So if you have a lever balance like this, you put a stone here, and then you put let's say a 1 kg here, and if it balances, you know that the stone must also be 1 kg. All right, this is a lever balance. Now, does this show that the stone has volume and occupies space? Yes, definitely. How do we show that it has volume? It has volume. We use a measuring cylinder. All right, you use a measuring cylinder, and you see a measuring cylinder here. It is measuring the amount of water that's displaced by the stone. So when the stone goes into the water, it occupies space, right? The stone will occupy space. And because the stone occupies space, you have to push the water a little bit, right? You have to push. So just like, if you go to school and your classmates you are lining up and friend want to like come in and stand in front of you. So your friend occupies space and as a result push you a little bit to the back. Okay, so the stone, same thing. When you put into the water, it occupies space, so it pushes the water out of the displacement can. This is the displacement can. A displacement can is like a beaker with a little spout. Yeah, this is a spout for the water to flow out. Okay, so yes, it shows that the stone has volume. Does it show a definite shape? No. Definite volume? No, it doesn't show the compression. All right, so it's only volume only. Okay, no mass, it doesn't show that it has mass at all. To show that it has mass, you need to see weighing scale or lever balance. Okay. Number 4, the diagram below shows two fully inflated balls X and Y balanced on a rod. When more air is pumped into ball X, what will happen to the rod? Explain. So this is an explain question. When you see explain question, what do you think of? Yeah, we think of CER, right? C stands for the claim or the choice that you have to make. The evidence, give me your observation as well as the reason why you choose that. Okay, so when more air is pumped in, what happened to the rod? Yeah, I know that if you pump in more air, right? Air has mass, so the ball X will go down. All right, so I will just say the rod, okay, the rod will tilt down at ball X. That is my claim. So what is my evidence? What did I see so that I know that it will go down? Oh, I see that because more air is pumped into the ball. This is my evidence. This is my evidence. So I'm just going to write down, so more air, because more air is pumped into ball X. This is what I see. This is my observation. And because this is my observation, right, I want to give an inference as well. What does it mean when you pump in more air into ball X? It means that so that it has more, and so you have more mass. More air in, so you have more mass. And why? What is the concept tested here? The concept tested here is because as air has mass. So this will be a complete answer. So just to take note of what is my evidence consisted of two parts. The first part is my observation, my direct observation. In this case, this observation is just lifted from the question. So actually, this statement is optional. Why is it optional? Because it is already in the question. So I don't have to write it. But I'm just writing it so that you know that that is what I see, all right, my observation. And because of what I observe, I can infer that that is why the ball X is going to have more mass. So this is my inference. Things that I cannot directly see. Okay, and R is the concept that they are trying to test you on. So I'll be asking what concept is the question testing us on. Okay, and in this case, the concept for matter questions will be definitely properties of matter. And since this is about air, he's definitely testing us on a property of air. So which property of air allow the ball X to go down? It will be air having mass, right? Out of the 4 properties, select the right one. Okay, let's go to question 5. Jacqueline poured some water into a communicating vessel as shown below, right? Draw on a diagram the water levels for B, C, and D. So the water levels at A is here, right? So C and D will be the same level as A. But B, the water level will probably be much lower. Now, why is this so? Because there's something here in B that stops the water from going up. And what is this inside B? Yeah, it is air. And we know that air occupies space, right? Air occupies space here. So the space has already been occupied by air so that water cannot go in anymore. And it's not just air, the air is trapped. That means the air cannot escape. Because A also have air, but the air here can escape, right? C also have air, but air can escape just like D. But B, it is trapped by this stopper here. So air cannot escape, so it occupies the space there and water can't go in. All right. So which property of water does the experiment show? The experiment show that water has volume. The water occupies space. That's why when the air is there, water cannot go in because water needs space as well, right? And what property of air does the experiment show? It also shows that air occupies space. All right, water cannot go in because the air is already occupying the space in B, right? So there's no more space for for water to go in. Okay. All right. Let's go to 6. Air is pumped into a container before using a pump as shown in the diagram below. What is the volume of air inside the container after 2,000 cubic centimeter of air is pumped into the container? Now, the capacity of this container is 1,000. All right. So when you pump air in, actually it does not matter how much air you pump in. The air will all be compressed into this container because air has no definite volume. It takes the volume of the container. When you pump air in, will the container become bigger? No, right? Will the water can will still be the same size. So the amount of space that this container occupy, let's say you're going to put all this container into your bag, the space that this water can occupy is still the same. It does not occupy more space. The can doesn't get bigger. It is not like a balloon. If you pump in air into a balloon from a small balloon, okay, you pump it into a big balloon, yes, the air is going to occupy more space because the balloon got bigger. But if you put it into a container like this that cannot increase in size, then the volume remains the same. It does not depend on how much air you put in because all the air will just be compressed in it. Okay, air will be compressed in this container. Air can be compressed. So what is the volume of air after 2,000 cubic cm is pumped in? The volume of air is not asking about the how much air molecules there are inside. No, it's about the space it occupies. So we are asking about how much space it occupies. And the space it occupies is the same as the space of the container, the metal can. So the volume of the can. So the space the can occupy, right? When more air is pumped in, does the can occupy more space? No, right? It's still the same can. So the amount of air, the volume of air is still still 1,000 cubic centimeter. The container does not become bigger. Air is compressed in it. And what property of air does this show? It shows that air can be compressed, or you can say air has no definite volume. All right. Number 7, another similar question. So if you have a metal box and the capacity is 500 cubic centimeter, and if you pump in 100 cubic centimeter of air, what will the final volume of the air be? So once again, I look at this metal box. Can the metal box become bigger? No, right? If the metal box cannot become bigger, then it doesn't matter how much air I pump in because the air is just going to take the same space inside the same box. So if the box has 500 cubic centimeter of volume, or occupy 500 cubic cm of space, no matter how much air you pump in, it's still, the metal box is still the same size. It's still going to take up 500 cubic centimeter of space. And what does this show? Again, it shows that air can be compressed, right? or you can say air has no definite volume. So what's the volume of air? I don't know. It's not definite. You have to depend on the container. How much space are you giving it in the container? Okay, let's go to question 8. The diagram below shows an airtight container filled with 20 cubic centimeter of water. This is a similar question. 20 cubic centimeter of water. This container has a capacity of 100, which means that it leaves a space here of 80 cubic centimeter for the air to occupy. All right. When you pump another 10 cubic centimeter of air into it, what is the final volume of air? So once again, I look at the container. Is the container able to get bigger? No, right? So if the container is not able to get bigger, the amount of air, it will just be compressed in it and be the same as the original amount of space for the air, which is 80 cubic centimeter. Okay? So what's property of air? So once again, it shows the air can be compressed, or you can say no definite volume, right? So and what property of water? Now, why doesn't the amount of water get less? Because water cannot be compressed, right? It's not like I pump more air in, the water will say, okay, let's squeeze and occupy a smaller space. It does not. So because water has a definite volume. Because water has a definite volume, or you can say water cannot be compressed. Okay? Question 9. Right, so Johnny filled a syringe filled with water as shown. Explain why he could not push in the plunger. Well, he cannot push in the plunger because it is water in that. And what can you say about water? Because water cannot be compressed, or water has a definite volume. Okay? It cannot be compressed. This is the same meaning, it cannot be compressed. Okay, it's the same meaning. You either say it has a definite volume, or you can say, yes, cannot be compressed. Both are accepted. You want to say both, also can. Okay. Number 10. Two measuring cylinders A and B have a capacity of 200 cubic centimeter. Each one is filled with marbles, and the other is filled with water. So both are filled to the 200 cubic centimeter mark. So when they poured all the marbles and water from A and B into container C, what is the new water level? All right. So we know that even if you pour A and B in, although this is at 200 cubic centimeter of marking, all right, these marbles will not take up 200 cubic cm of space, because there are a lot of air spaces in between. Because of these air spaces in between, the water will fill up the air spaces, so the total volume has to be less than 400, probably about 300. You just draw any water level that is less than 400, less than 400. Okay, so the water level has to be less than 400. Why? Why? Because explain your answer. Let's try again. Explain meaning CER, the claim, evidence, and concept. In this case, there's no claim. They are not asking a question. So I just give the evidence. What did I see that tell me that, oh, the water level will not reach 400? Oh, I see that there are air spaces between the marbles. So I see there are air spaces between the marbles, right? In between the marbles. Okay, that's it. Okay, so that's my evidence. This is what I see. And because of that reason, so because air spaces, so what? So why wouldn't water level go up? Oh, because so that the water will occupy the space. So the reason here is always what concept is it testing us on? Is about one property of the matter, one property, in this case, property of water, and it is water occupy space. So I'll write down water occupy space. Occupy space in the air spaces. Will occupy the space in the air spaces between marbles. Okay, so the key idea here is water occupies space and the air spaces between, so that you look at keywords. These are important keywords. The keywords will be air spaces between the marbles, so that water will occupy the space between the marbles. Okay, all right, let's go to question 11. Mary set up an experiment. What will happen to the water level in the cup after some time? Right, if you have done this experiment, you will see that the water level will decrease. The water level originally is here. You will go down less, right? You might go down here. Why? Because as you blow in more air, there'll be more air in the cup and you will therefore occupy more space because air occupy space. The more air you blow in, the more space it will occupy. So what happened to the water level? Explain. Let me explain means the CER, right? The claim, evidence, and concept. So my claim, what happened to water level? My claim is the water level will, take note now, it is the water level, not water. The water level, level is the line. Okay, this is the line. So the water level here in the beaker, basin, this is the water level in the cup glass. This is the water level in the cup or the glass decreases. So you talk about water level just increase or decrease. Evidence, how do I know that? Because I see, what is my observation? I see more air is blown into the cup, right? So more air is blown into the cup. And what can I infer? All right, so infer, I'll just it's just the same as concept here. With more air is blown in, you occupy more space, right? And so it occupy more space. All right. So, and the reason, the concept is basically, what concept are they testing us on? Will be actually as air occupies space. It is a little bit of repetition. So actually, if you return here, occupy more space, you don't really have to repeat again. All right. But I think it's useful to, but you should add in and push the water out of the cup. Now, this statement should be written because you want to answer about the water level. If you don't have this statement, then the whole question has no mention about why the water level decreases, right? So more air occupy more space and therefore push the water out of the cup. So this will be the answer. Okay. Number 12. All right, so this is a funnel with water. Explain why the water flows in very slowly. Again, what is in the conical flask? There is air, and air occupies space. Right, air occupies space, but it's not just air, it is trapped air. The air is trapped. The air has to be trapped for it to occupy space, right? Otherwise, you just escape, right? And water can go in. So I explain why. So again, CER. In this case, there's no C, right? There's no C. So I'll just go to the evidence. Why do I see that water won't go in quickly? Because I see there is air that is trapped in the conical flask, right? So air in the flask cannot escape. Either you say cannot escape or you say it's trapped. It's the same thing. Okay, and when it cannot escape and occupy space. So the our part will be that an air. The concept here is the property of the air, and air occupy space, right, in the flask. Okay, so the R part usually is just a concept. What is the property of the air? And you have to mention the air in the conical flask. Please mention in the conical flask. Don't just say the air, because air can be inside or outside the conical flask. Air cannot escape. Either you say cannot escape or you say it's trapped. Both are fine. Okay. So if there is a glass tube, why did the water is the water able to flow in? And that's because the air in the flask can escape through the glass tube, right? So water can flow in to take up the space. So explain CER. There's no C, right? I'll just go with the evidence. Why? What did I see here in the diagram that tell me that, oh, water can go in? I see the glass tube and air can escape through the glass tube. So I'll just write down air in the conical flask can escape through the glass tube. Make sure that you mention the glass tube because they give you that. So air in the conical flask can escape through the glass tube, and therefore the R part, so water can flow in. To occupy the space, you need to have the word occupy the space or take up the space. Okay, I can just add in previously taken by the air. Okay, this one is optional. So the keywords here will be air in the flask can escape, okay, through the glass tube. And so water can flow in, so water can flow in to occupy the space. The key concept here will be water occupy space. So air can escape and water occupy the space. All right. Now, last question here. So Ali pushed in 2 cups A and B. There's a hole in B but not in A. Draw in the water level. All right. So in B, because the air in it can escape through the hole, the water level will be the same as outside. There will be water here to the same level. But A, the water will probably be just kind of go in. So explain. Now again, explain means CER. There is no C. So I just give my evidence. Since there are 2 cups, I should talk about both the cups. Both the cups, not just 1 cup. Talk about both the cups. What do I see? See, evidence is your observation, right? Evidence is your observation. What do you see? All right, plus inference if you have. So I'll just say the cup A. Sorry, not cup A. The air in cup A is trapped. I see that there's no hole. That's my observation. My inference is the air is trapped. All right, the air cannot escape. So air in cup A cannot escape. All right, B, but the air in cup B can escape through the hole. That is my observation. So reason R is the property, right? What is this testing us on? The key property is testing us on is air occupies space. So, right, this is the trapped air, right? The trapped air in it occupy space. Yeah. So the air in cup A occupy the space, right? But water can flow in to cup B. to occupy the space previously occupied by air. Bracket, previously occupied by air. That's it. So the keywords here will be, the evidence will be air in A cannot escape. All right, so the air in A occupies space. For B, will be the air in B can escape through the hole, right? But so water can flow in and occupy the space previously occupied by the air. Okay, so that's all for this topic. I hope you have learned something. If you have gotten the questions wrong, all right, you do not know how to do, please make sure that you redo the question. It is very important to redo questions that are guided, so that you are able to do it on your own. Okay, all right, so that's all. I see you again. Bye bye.